Oh, my name is Prince Efwe. I'm the CEO of Light Solutions Limited. Aside being the CEO, I am a software developer, engineer, and also an artificial intelligence machine learning engineer. So I have over 15 years experience on that particular skill. So that's a brief information about myself and what I do.
Okay, that's good. Okay, you can share your slide now. So we start.
I'm sorry, I didn't prepare any slide for that. I thought it was a oral discussion webinar. I really didn't have any slide to share.
Okay, that's a good one.
Yeah,
So
so I'll be talking from experience. Yeah.
okay, then let's hear from you. I'll expect to know more about it. Thank you.
Yeah. So, like the topic of the webinar, looking at procedural-oriented programming versus object-oriented programming. Yeah, procedural-oriented programming is something that's like the foundation of programming. When programming languages were still in their very crude state, so they weren't really that matured or having a reusable block of units like the way recent programming languages are. So to say, programming as at then is a very painstaking, a much more painstaking, still painstaking, but a much more painstaking career, because for everything you want, you have to build. There are actually no shoulders of giants for you to lean on and take off from there, so to say, to make the job easier. So procedural oriented programming, as a basic concept of programming, it's like writing little programs for the system to do. There was nothing like object encapsulation where you could make a particular class or properties immutable and constant, not prone to unwanted changes. So it's a style of programming in a very crude form that you, as a programmer, you're using such programming languages that are solely operating in that nature. You have to be very careful, as every slight unwanted changes to your codes can produce unwanted side effects that will take you days to even debug and know where the issue is coming from. Procedural oriented programming, from experience, I used it when I was doing QBasic, when I was doing Fortran, when I was doing COBOL, a bit of C++ as well, a bit of C also. Much more writing very primitive programs for computer to use. So those kind of programs that just run on the command prompt system, the command window of no much graphic user interface. Programs such as embedded programming, programs that are to be embedded in microchips. So they follow those procedural patterns. But over the years, with the invention of high level languages such as C Sharp, Java, and the likes, PHP and the likes, the object oriented programming style became the thing in vogue, which brings a lot of ease to programming. So object oriented programming is such that you build objects and classes, give them properties that defines. Let's take for example, you're writing a program that has to do with maybe filing of applications, and yes, humans are the ones who file that application. So you can create a class to mimic the human object, to say name, first name, middle name, last name, age, address, probably basic salary, and then you could also have a property in that object that says annual turnover. Now, the annual, we know that there are 12 months in a year. So in that property you've created, you could just make your annual turnover to be a multiplication of the basic salary entered by the user by 12 to just automatically give you the annual turnover. So you see the beauty of a object-oriented programming. And once you've defined a class, you inherit from that class to create further objects of that similitude. And then the beauty of it is, except you consciously go to change properties in that object, it stays that particular way. It brought a lot of ease to programming, brought a lot of strictness that helps prevent bugs in programs. I would actually say in from experience in real world building an enterprise software, there is no way you won't use both of them. At some point in time when you need to create functions, procedural calls to just do a specific task, you go the procedural way. When you have to start dealing with objects such as probably maybe a book in a library, applicants to that library, those are objects. You have to do the object oriented programming. So in today's world, any true enterprise software, we use the both of them, the both styles in it. And good for the kind of programming languages we have around now. We have a lot of them. They give you the flexibility to do all of them. Even as primitive as JavaScript was back in the days, JavaScript has evolved into object-oriented programming style in the class of TypeScript. TypeScript is an inherited form of JavaScript. And the essence is to make JavaScript now have object-oriented programming style. That's something that now looks like C sharp and the rest to give programmers this ease of writing program. And the new wave with which the programming languages are now makes it easy for a programmer to port from one programming language to another. You see the same style, the same format, just a few changes in the syntax, and you are good to go. So you can port the same concept, the same practices, everything flows. It has really brought a lot of ease to the world of programming. So to cap it up, the object-oriented programming and procedural-oriented programming in today's world, they go hand in hand, depending on which aspect of the program you're writing at that point in time. Thank you.
Okay, thank you so much, Mr. Prince.
Much, Chris.
I really gained from what you said that procedural programming and object-oriented programming go hand in hand. Now, my question comes to this part of, we are building some special robots. Example is a drone. When you're building a drone, there is a place whereby you have to build it in a procedural way. Why? Because it's not, it does not have the time to fetch from one, what do you call this, from one aspect, from one inheritance or the other. It's procedural. That means I want you to go right, you go right. I want you to go left, you go left. I want to move center, you move center. So that means it's just a one-way thing, like a form of a monolithic design pattern. So I don't know if you have anything to say about that, about you have to build this structure and you have to use a procedural way. You are not involving the object-oriented programming.
If you Yeah, so if you play back to what I said earlier, I talked about certain kind of languages. I mentioned embedded programming and I mentioned chips. When you're talking about drone, you're not talking about software anymore. You're talking about embedded programming, whereby the software program is embedded into a hardware. I said that's where you see the procedural coming up because at that point in time, you're really not dealing with objects coming into bringing so much information. There's already a defined way, an algorithm. If this happen, go this way. If that happen, take this decision. That's strictly procedural, and it falls under the example I gave earlier, which has to do with embedded programming, production of microchips, and that's what you see in drones. So when it comes to that, you definitely see that the languages they are going to use to write such program are low level languages that interacts with chips, yeah, and they go strictly the procedural way. That's so when it comes to embedded programming, you're going strictly the procedural way. But when it comes to main software applications for business case and all that, the both comes in. So the robot you gave an example of is the drone you gave an example of is something of the embedded programming. You open a drone, you're going to see chips inside of it. There'll be no keyboard for you to start entering first name, last name, and all those. No, no, no. It just has to do with control and how it has been programmed. The program is directly interacting with the hardware, giving specific instructions to the hardware. So that's purely procedural.
Okay, thank you so much. Thank you so much. There is another aspect of what do you call it, procedural that I want to discuss with you, which when you're using your neural neutron. So neural neutron is, it's I'm fetching a particular data and I want to use to compare other data. So I'm saying, okay, I want you to just compare this data within a second and give me a result to see which one is right or which one has the accuracy of it. Example of it is building a voice AI. So, building the voice AI, you're using it in a procedural whereby I don't need to call a class. I don't need to call an inheritance. I don't need to call an object. So what I'm doing is that this is a procedural language. When I speak to it, I need a response at once. I don't need to bring another class into it because of the microseconds of it. So, implementing it in that object-oriented programming language, I think is going to cause a lot of backlogs, a lot of seconds that is going to be wasted on optimization. So I think procedural language is something that you can use for that so that you can get it at once. Okay, I call this command, I check it. Okay, this command exists. Oh, the OS can check it. Okay, yeah, this command exists, and it give you a response back.
Yeah, so yes, that's a unique example, and I will delve into the aspect of my work, which is artificial intelligence engineering. When we build chat robots, we deploy data models for probability functions and all that. I specifically use Python for that. Now, Python is I will call Python a high level language. So depending on the use case, Python can do object oriented programming for me. Python can as well do procedural programming for me. So on that specific use case of a voiceover, you want to compare this data to this data to see if there's a difference or there's a similarity, or you feed a particular input, let's say for medical purposes, you take some parameters from a patient, input them into the computer, and the program is to tell you if the patient is prone to diabetes or not. Now, at that point when you're feeding that information into the computer for that AI functionality, it's a point of usage. And those information you are feeding into the program are also going as a class or an object. You know what was happening in our recent in the recent time is we've so much, I also say for a marketing purpose, we've so much talked about AI like it's a standalone thing. It's not. It's not. I, for one, today, I am more in the anti-money laundering aspect. So the models we've deployed to banks to curb fraud and the likes and all that, they look so procedural. Oh, if the transaction flows this way, depending on what has been done, the training data, the test data, the record precision and all that, is this likely to be a fraud situation based on what the model has been trained on? It looks so procedural. Now, that is just one aspect of the whole program. That full AI structure is plugged into our software products. So the user will like, oh yes, this product from Infly Solution has AI capabilities and all that. Those are what we've sold to them to buy the product. However, on the programming part of it, when the user is interacting, you're sending in classes, sending in objects down to the AI, that the AI will now treat your data, pass them into the program, into the several neurons to use to check its training format to see if it's in the case of by probability binary predictions, if it's either prone to fraud or not prone to fraud. So the aspect you gave now is just the extreme end of that AI part. But when you're looking from the user's aspect, because if you bring just the AI part, the user can't make use of it. They need an interface, they need a place where they put in their data, they need a place where they send in their tests as charts, all those things. So let's take a chatbot, for example. So I'm typing with a chatbot on Google search engine. What are the things that could make someone prone to insomnia? It looks like I just sent a message to the chatbot and it gave me a response. On the programming part, that message went in a class as a test. Something went under as time, another thing went under as IP. You see those things that are going in the it's an object. It's
Okay.
an object. The IP, so you see what I said earlier, that they go hand in hand. But because of the way, mark the power of marketing, when they want to make people feel something new has evolved. Meanwhile, it's still working alongside with the existing. So that's why, if you look at it from down, we look at it as if it's just strictly procedural. It is still object oriented mixed with procedural programming that it's actually happening. Yeah,
Okay, I get your part. The object-oriented message procedural programming. So it works hand in hand. But if you're looking at
exactly.
object-oriented programming, it stands on its own. Why? Because when you break down object-oriented programming, you can pick out your procedural programming. But for the aspects of your embedded system, easily you just use your procedural programming. Then you can now implement some object-oriented programming in another aspect, and you can now consume them and bring them together in another form, in another format, in which makes the application to know, okay, this is what I need to do for this. This is what I need to do for this. So I'm talking about it when I was working on there's what they call the block backward differential equation. So it's something I did is not years back, and it deals with, okay, I can want to calculate the speed of a jet, how fast a jet is. I want to calculate it. A jet deals with, it just move in on its own speed. When it just moving on the speed, you want to create a model that can fit into it, whereby if the jet move on a particular speed, right, it works in the rate you can control it, and it will not go out of function. So it's the kind of model that I think I worked on, in which, though I had to stop for some while, but with that I make use of Maple programming language. So we get the data, we test it with different data, we test a different formula. I was able to use Maple for it, convert Maple to write some kind of objects. But before that, I started with the procedural programming language. So that's part of the experience I did using procedural programming language, because it started with MATLAB. With MATLAB, it moved to Maple. That's Maple 18. Yes. So I'm saying this because from there, then you can now move it to the object-oriented programming language. So some research starts with procedural. Then when they see that procedural can't handle it, then they move it towards to object-oriented programming language. So because inside of object-oriented programming language, there's procedural programming language implementation in some aspects. Okay, Mr. Prince, are you there?
Yes, I'm with you. Yeah, I wanted you to land. So even from your explanation now, you actually see the handshake between both.
Yeah.
Yeah, from one to the other, back and forth, depending on the actual aim or the goal at hand at that point in time.
Mm.
Yeah. So when you're talking of MATLAB now, I didn't use MATLAB, but I use much more primitive Fortran, COBOL, and the rest that are
Okay.
strictly procedural. Yeah, at times in research, you want to build a concept. Once the concept is established, you take it into a much more advanced platform where you now start using object-oriented programming and all of that. I remember back then, 2005, when we were building programs for my school back then for calculating resistors in parallel, in series, computation of GPA, we're using QBasic and the likes. Those are strictly procedural. When we're able to establish a concept that this algorithm actually works, the full procedural call was now taken to be just one function in the main application. After which, when the user enters their values that goes as an object, it is sent to that function to produce an output. Yeah, so that even is similar to exactly what you described, where you started from MATLAB and then you went to Maple and all that. Yeah.
Okay, thank you so much. So the 20 minutes has elapsed. So the next is Mr. Kayode. Can you please share your slide? Then it starts from there. Thank you so much.
Okay, hi guys. Can you guys hear me?
Yes, 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 we can.
Okay. Yeah. So just give me a second so I can share my screen. And again, I mean, it's actually a very it's a privilege to be here to talk about why we like when procedural programming should be used over object-oriented programming, right? So before I get into that, let me just give a brief introduction about myself. So I've been in tech for like over 5 years now. I mean, not as a not as a programmer, but as a uh, project manager, Scrum Master and the likes, right? So, I mean, I might not be very technical in my analysis of, when the procedural programming should be used of object-oriented programming, but, but like, based on my exposure on how, uh, a software development works and stuff, right? So, being in different team meetings and you know, uh, you know, project planning, talking about okay, what approach works best, which one to use for what project and stuff like that. So that pretty much informs what I'll be sharing today. So going into uh the whole thing proper. So like in software developments, right? And then I mean, I assume some people might be listening that might not actually understand deeply what software development means, right? So software development is just like a process, right, of designing, creating, and maintaining software, computer applications, whether on the web, on desktop or on mobile, right? And then but in terms of what we are talking about, this is the aspect of creating software applications, right? And then selecting the correct programming approach. Everybody knows is quite vital, right? So that we can have efficient and maintainable code. And in terms of maintainable code, right? So I would like to, because I like to give illustrations when I'm talking. So maintainable code is, for example, like you building a house you can actually maintain, right? So if you don't have a code that you can maintain, if you don't have a code you can maintain, that's not efficient, and it might actually limit the kind of people that can work further on the code. For example, maybe you have a team of engineers are like 10 in your organization, and then let's say 5 or 6 of them leave your organization. If you don't have a maintainable code, when you bring in new people, they might find it hard to, find their way around the code, know what to do, solve specific problems and stuff. So procedural programming and object-oriented programming, right? They're like the two significant approaches. Each of them, like from what Prince and Israel have been, what you guys have been speaking about before, like each of them have their own strengths. They have their weaknesses, but for the purpose of this talk we're having, like to deep dive into like procedural programming itself, like why we should choose it, like when to choose procedural programming over object-oriented programming. So what is procedural programming, right? So procedural programming is like a traditional approach where the focus is on writing procedures or routines that perform specific tasks, right? I mean, my background in project management, right? So I can liken procedural programming, I mean, to let's say waterfall project management technique, right? It has, you write down the procedures, the routines that is needed to perform specific tasks, right? Just like listing it step by step, this is what to do, this is then, it follows a specific procedure, right? And then it also involves breaking down a program into smaller reusable functions that can be executed sequentially. So just like waterfall, project planning principle, for example, you're building a house, right? I mean, that's like the most generally used example for waterfall project management technique, right? From when you draw out the plan. I mean, you ideate on, okay, what do we construct, right? And then you start talking about, okay, what would it look like? Then that's like drawing out the plan. And then once you draw out the plan, then you start talking about foundation, like doing all of that. So a uh it follows a process. Then you've broken it down into smaller functions, right? And then it has to be done sequentially. You can't jump from one stage to the other. You can't jump from, let's say, stage 2 to stage 5. It has to follow a sequence, right? It's also, procedural programming is known for its straightforward structure, and it's often used for simpler applications or projects where the complexity is relatively low. So in trying to explain this, right, so I want to think of let's say when you have an MVP, you're thinking of building an MVP product, right? Just something that the scope is very small, It's very simple, but you just want to get something out quickly. It's low complexity. It's just like maybe one or two functions, one or two features. Just want to get it out as fast as possible, right? So, you know, that is, like trying to explain what procedural programming is. And then just a brief introduction about, I mean, I'm not going to draw more on object oriented programming, right? But like just to give a brief description of it, is a modern approach that revolves around organizing data and code into objects. Each object represents an instance of class, which encapsulates both data, attributes, and method functions. I mean, and then it promotes object-oriented programming promotes the concept of reusability, modularity, abstraction, complex applications, and efficient code management. I mean, those are some of the strengths of object-oriented programming. But thinking about, because the essence of this talk is to understand when to choose procedural programming, right? So, when building a software application, right, and you're like, okay, like, what approach should we use? One of the things that, uh, one of the things to consider choosing procedural programming for that software development is, when you value simplicity and speed. You want, the project is simple and you want to get it out fast, right? So, procedural programming is better for small applications that needs fast execution due to, fewer object-related processing steps, right? I think I gave an example of when you want to build a minimum viable product, you want to get to the market quickly. You just want to build a small feature that that you think your customers need, right? You want to build it, as fast as possible, as simple as possible, get it out as fast as possible, right? You can choose uh, procedural programming, to do that. And also, another reason or another scenario that can make you choose or things to consider when whether to choose procedural programming or not is if you have resource constraints, right? You don't have, big budget, you don't have, large team, uh, you can choose procedural programming for that, right? And then if you have legacy code bases, like legacy code bases are like, uh, you know, a project that has been existing for a long time, the code base is there, and then I mean, it's best to stick with procedural programming because it's easier maintenance. It's practical for consistency and the likes, right? And then what another factor to choose that you can consider to choose procedural programming is when it's an algorithm centric task. Tasks that are algorithmic centric and don't require complex interactions between different components, right? Procedural programming provides a clear and concise solution, for those kind of tasks. And also, if you have a small team, like you don't have that large team, similar to when you have constraints in resources. You know, uh, Hello, can you guys hear me?
This one is that in cinema.
Hello.
Hello?
Yeah, I can hear you.
Oh, what is
Okay, awesome. Yeah. So, when the team is very small, you don't have a large team, right? It's good to choose procedural programming for that. You know, it's best suited for teams that are small. So yeah, I mean, those are the scenarios. Those are the uh, things that determine the things that determine choosing procedural programming for your software development, right? And then just to conclude, right? Just like I've said, procedural programming and object-oriented programming, they all have their own strengths. They have they have things that they're super suited for. They have their uniqueness and stuff. So deciding between which one to choose, right, depends on the needs of the project, how scalable the project is, and familiarity and all of that. So yeah, I mean, just like what I've said initially, if you have a small team, if you have you know uh, resource constraints, and all of those other points that I've mentioned previously, I think those are like the best reasons. Those are like the determinant factor to choose procedural programming over object-oriented programming. Right. So yeah, that's pretty much it, guys.
Okay, I think this one is short and precise. That's good. So I'll say it's a good one. I think Mr. Prince already talked about a lot of what you were presenting, but you're able to
Yeah.
break it down to a small maybe language. And I'm a small boy and I'm still learning. So yeah, so thank you so much, Mr. Kyle Adiosho. So I don't have any question to ask. So I just love the design of your slide. I really appreciate it. Please, can you send it to me after this? So
Okay. Yeah. Sure, I'll
okay,
do that.
okay, thank you. So next person is Mr. Delany. So
Yeah, hi everyone, good afternoon.
good afternoon.
Um, yeah, I'm also going to be sharing slides, so if you can give me a few seconds. All right, so is my screen visible?
Yes, it
Hello?
is. Yeah.
All right. So yeah, thank you to the speakers who have come before me. You guys already explained most of what I was going to say. But I'm going to be coming from an angle. I'm someone who uses object-oriented programming a lot. So I'm just going to go over some things which I feel were missed. So I think I'll start by saying what programming paradigms are. I mean, there are so many of them, aside from just procedural and object-oriented. And programming paradigms are simply just different ways in which programs can be organized. So as I've written here, there are a set of ideals and guidelines, basically agreed on by a group of people. And some programs, or rather programming languages, are created with particular paradigms in mind, while some programming languages are multi-paradigms. As Mr. Prince said, they can go hand in hand. So programming languages aren't strictly tied to programming paradigms. You can mix and match basically. Um, so yeah, procedural programming, as everyone has already said, is a derivative of imperative programming. Oh, I don't know if anyone said that. But what imperative programming is basically a structure in which a set of detailed instructions are executed in a given order. And where procedural programming takes it a step further is structuring these into functions known as procedures or subroutines. And it allows for modularity and organization. Modularity being the fact that you can separate these functions into independent pieces that accomplish separate tasks. And it allows it to be easily testable. You can easily maintain it. Um, yeah. So I also had like some examples here. For example, if you were creating a program to give a talk at a webinar like we're doing now, what do you want to do? You want to prepare your slides, you want to join the webinar, you want to give your talk. So imperative programming will have these steps all listed down in that order. But with procedural programming, you can break it down into functions that all run and then run the functions one by one. So as you can see, we do the research, make notes, create a slideshow like I'm showing you. You join the link and you present the slides and explain the slides. So procedural programming is quite straightforward. And I think that's a word I'm going to be using a lot during my talk. So with object-oriented programming, um, it's basically organizes software design around data rather than the functions and the logic needed for that program. And how it does this is it represents data as an object, separates constants into entities represented as objects. And each of these objects has information that is particular to them, also known as properties, and actions that they can perform, also known as methods. Um, and one key thing with object-oriented programming is that we make use of classes, which are basically blueprints for objects. Classes are just the plans for what an object can do. And these objects created from classes are called instances. So where object-oriented programming takes it a step further from procedural is that it adds inheritance, abstraction, encapsulation, and polymorphism. So these are things I wouldn't be going too much into detail about, but yeah, sorry. they add more complex levels to programs. So another example here with the same concept we're talking about is giving a webinar. So if it wasn't a straightforward program where a speaker joins the webinar, you then turn to something like object-oriented programming. So as I wrote here, imagine we are three speakers talking about this. And imagine one speaker was supposed to talk about object-oriented programming and another speaker was supposed to talk about procedural programming. If you're writing the program for that, you probably have to write two different programs where one speaker speaks about procedural and one speaks about object-oriented. But if you're using the object-oriented paradigm, you can have a class for a speaker and they have similar properties, which are the slides or the topic they're going to be speaking about, and similar actions, which is basically talking about those slides. So as you can see, it makes abstraction easier. Slides can also be an object. So data, like I said, the software is designed around data and not just the logic. So in the next slide, this gives an example of how that program would be run. As you can see, there are different objects, different slides, and different speakers. Now, why I said it adds complexity and allows you to add complexity, imagine after this webinar, there was a second webinar where, for example, I have to join and I'm speaking about both. So in my pseudocode, you can see that the two speakers are initialized and join the first webinar link, but they have two different slides. Slide one is slides about procedural programming, and slide two are slides about object-oriented programming. So we both joined this, and John, the first speaker, gives his talk, which is about procedural programming, and James joins and gives his talk about object-oriented programming. So in the case where, for example, John now has to join another webinar and talk about both. Again, with procedural programming, you will need to write another program that runs through all this. But with object-oriented, all you can do is add a method which changes the slide, changes the link. And as you can see, the same object, John, can then join the second webinar and give his talk on both slides. He gives the talk on the first one, which he still has, which is procedural, changes the slides to object-oriented and gives his talk. So as you can see from this explanation, object-oriented programming can be used for more complex programming needs. But what we're speaking about here is procedural programming. So factors you want to consider when you are choosing what programming paradigm to use and when to use procedural programming, like Sakayede spoke about, project size, when it's relatively simple and the logic is straightforward, then procedural is the way to go. Like I said, I'll be talking about straightforward a lot. Object-oriented programming, like you see in my example, there's a lot of complexity because of hierarchies and relationships, which I did not even include. Like this is a very simple, high level, high level interpretation of object-oriented programming. I haven't gone into inheritance and relationships. Secondly, performance and resources. When you do not have um, enough resources or you want to keep your performance high, you go with procedural. So for example, in object-oriented, let's say it takes 1 second to instantiate any object. As you can see, we already have 1, 2, 3, 4, 5, 6 objects being instantiated. So that's an extra 6 seconds of overhead. 6 seconds may not sound like a lot, but when you are developing something that needs to run in microseconds, this is overhead. And obviously, all these variables take space. So yeah. So again, procedural programming, straightforward, does not take space, is very highly performant, and that is when you want to use it. Again, when the domain is linear and doesn't include other domains. So when I mean domain now, I mean the problem area, the data involved with the problem. For example, with this example, we are talking about giving a talk at a webinar. But when you extend it to giving multiple talks at webinars, switching context of your slides and everything, it becomes more complex, and procedural programming is not the way. But when it's straightforward, join a webinar, give a talk, then procedural programming is the way to go. And last, again, simplicity, which I think just encapsulates everything I said here. Procedural programming is always a simple way to go. Um, so yeah, real world examples are like small scripts, utility tools that perform very straightforward tasks like converting units of distance or image processing or mathematical operations. Everything here are all almost the same. Straightforward, they don't require too many resources, they're supposed to be highly performant, and they all lie in the same domain of the problem. Uh, so I have an example here of a procedural code. What it does is converts meters to inches and inches to meters back and forth. So as you can see, it's rather straightforward. We have three functions broken down, and the main procedural code here is straightforward. It takes the choice by prompt by the user, and depending on the choice of the user, runs that function and straightforward. Like there are no objects being created. There's no need for inheritance or relationships. It's a very straightforward programming. Um, I'm going to go back just to speak about something Mr. Prince said, how they can go hand in hand. So in my pseudocode example for object-oriented programming, as you can see, this method, give talk, still uses procedural programming because give talk is a straightforward thing. You have your slides and you explain them, and that is where procedural programming comes in. So yeah, I most speakers before me have already spoken and taken a lot of words out of my mouth. So I hope I've been able to shine some more light on when to use procedural programming. Simple, straightforward tasks. And again, like Mr. Prince said, they can go hand in hand. So using procedural programming, or rather using another programming paradigm like object-oriented programming or functional programming doesn't mean you cannot use procedural programming. So yeah, again, in conclusion, due to the straightforward nature, what I said I'll be using a lot, it's best to use it when the program is simple, straightforward, and does not require complexity. Uh, so yeah, that is really my slide. Straightforward as procedural programming is. Thank you.
Okay, thank you so much. Thank you for the codes. Thank you so much, Telani. Thank you for the codes. Thank you for the programming. No, it has been a long time I've seen that kind of interface for programming. I really appreciate it. I saw your code and I remembered is it facade pattern? Design pattern, facade pattern that you just use prototype. You're using JavaScript. So instead of you
Yeah,
maintaining this, you just use prototype, then you now call that object with it again, and then it does its work. So instead of you going back and calling that same what do you call it class, you just call that class dot prototype, use prototype, then you call it in, or you use what do you call it? There's another pattern I usually use. Instead of you calling them what do you call it, that object at once. So you turn that object to a function and then you'll be able to what reuse it again and again and again inside that same function. So there's a way to do those things. They use the chaining method. So I have with addition with
That's a recursion.
yeah, it's recursion. A recursion with it.
yeah,
Yeah, so a lot of those things have been done. We write it, we want it to be very fast, we want it to be optimized, scalability, reusability, all those functionality. It happens for each of every code you write. Every basic, is it C, is it C++, is it Pascal? Mr. If have you written Pascal before?
You said?
Have you written Pascal? Pascal programming language.
No, 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 no.
Pascal too. I wrote Pascal when I was in University of
Okay.
Lagos. Yeah, Pascal. Yes, I wrote Pascal. I wrote MATLAB. I wrote C. I wrote C++. Yes, I wrote C Sharp. I wrote Java. I wrote Python too. So all those things were done in the University of Lagos. But my project was defended using Maple. I had to go and study Maple from scratch to use it for the theory, to use it for the test of the research. So with that, I had to learn more about procedural programming language and how to implement it with object-oriented programming language. So when was I implementing the object? That's when I had the idea of doing all this AI, all this research of NLP. I had to pick this model. You have to test it with other model. So with that, with what Delano was showing, so I had to create it. Okay, this object, this is own. I'm going to run it. This object, this I'm going to run into this aspect. So it got to a stage my system could not bring out results again. All it was doing was the system was just crashing. So I had to just send it to my friend that is in a bigger system OS. So with that, I was able to run it and it brought out the results. So with that, I saw that sometimes when you use your system and you're writing your codes, the system will just malfunction. Why? Because it's more than the system. So with that, I was able to have those ideas. So when I started inputting data, that's when, so when you're using data, then you have to include your object-oriented programming language. So with that object-oriented programming language, and I said, okay, so it has moved from procedural from a one way to what? So you have to implement your data, you have to control those data, the data have to bring out a graph, you have to plot those data, you have to, okay, why is this data being like this? Oh, why am I getting this? Why am I getting this? So with that, it's something that is broad, but with experience, I think we can get more understanding of the procedural programming language and the what object-oriented programming language. Thank you so much, everyone. I want to call today's webinar to stop with all our experiences, and then I'll say it's been an honor to host today's webinar. And then I don't know if you have anything to say, Mr. Efe, Efwe, sorry, Prince Efwe.
Yeah, all I want to say is a big thanks to every speaker. Um, it's an honor to share from your experience, your knowledge, your well of knowledge, and I'm grateful for the webinar. It's a knowledgeable one. I'm grateful.
Thank you so much. So, Mr. Delany, what do you have to say?
I think I'm just going to echo what Mr. Prince said. It was really an eye opener because I prepared my slides and coming and basically these speakers going before me and almost explaining everything I was going to explain. It was really nice. I really enjoyed what Mr. Prince spoke about data models and his experience with that. Yeah.
That's good. Okay. What about Mr. Kayode?
Okay, yeah, I mean, to be in the midst of programmers that are actually using, this day in day out, right? So I mean, it's an exciting opportunity, and it's a great privilege to be amidst you guys discussing this topic. And I mean, I learned a lot from what everyone has spoken about, real life experiences. Yeah, it was a good one and filled with a lot of learnings and stuff. So yeah, I'm glad to be here.
Okay, thank you so much. And I'll just say that please, I'm going to drop the link for the YouTube channel so that we can share with friends, let them learn, let them see what we're able to say, what we're able to learn about this, and so that they can what be particle of what data we have given out. All these things are data, so they can know more of what we have done about procedural and then object-oriented programming language. And Mr. Delany, thank you for the codes. Mr. Cody, thank you for the slide. Mr. Prince, thank you for all the experiences. And I'll thank myself and I'll call it a day. Thank you. Bye bye, everyone. Yeah.
All right, guys. Bye.
Yeah. It